Hi, good morning. Welcome back to Intro to Speech Understanding. So today is the last regular lecture, and this is probably going to be a short one. I've introduced to you the key ideas in text-to-speech synthesis. I showed you how speech production is an excitation that happens once every time your glottis closes. Every time your glottis closes, it stops the airflow, and stopping the airflow causes a negative pressure spike. That stopping of the airflow at your glottis causes echoing inside your vocal tract, resonances that cause you to hear the vowel that is being produced. Consonants are produced by closing your vocal tract with your tongue or your lips at different places along your vocal tract. And last week we talked about how that leads to linear predictive synthesis, how we can do linear prediction in order to decide what speech is going to be synthesized. This week, I just want to introduce you to the application programming interface for the Google Speech Synthesizer. This is going to be the last lecture, and this is really a fairly short homework. So let me just talk about this. The Google Speech Synthesizer, of course, is an online synthesizer that's made available by Google to anybody to use if they want to, and um, and it's made available through Python using this GTTS application. So let me see if I can move this. In Python, we have this GTTS application that allows us to access the Google text-to-speech synthesizer. So first of all, you just need to install it. You can do that by typing pip install GTTS. Actually, the hardest thing about GTTS is just remembering where the capitalization goes. Because when you install it, you need to capitalize the T and the T. And when we run this, we'll see that I've already installed it. And, oh, actually, I needed to install it. When you import it, you capitalize none of the letters. So when you import it into Python, it's using G small letters T, TS. And when you run the function, the module is all small letters. And the function that creates a synthesizer has capital T, capital T, capital S. That's like really surprising, right? We've got something that has two to three different kinds of capitalization. Either the T's are capital or nothing is capital, or the T's and the S are capital. That's really the hardest part, the hardest thing you need to know about it. Basically, you create a GTTS object using a text that you want to synthesize and specifying a particular language, and then you save it into an MP3 file. The other tricky thing about it is that it will only create MP3 audio format, and the only audio package that will load MP3 is Librosa. Fortunately, we've been using Librosa, so you can just type librosa.load speech.mp3, and then you can play it.
これは合成音声です。
Right? So I put desired text as これは合成音声です, or I can put it in English if I want. And let's change the synthesis language to English.
これは合成音声です。
Oh, because I called it. Well, that's interesting. It said kore wa gosei onsei desu with an English accent, with an American accent. Let's change it to this is speech synthesis.
This is speech synthesis.
And now since we've done Japanese with an American accent, let's do English with a Japanese accent and see what it sounds like.
This is speech synthesis.
Right. So it sounds like a mockery of the accent, but it's actually not a mockery. It's created by taking these particular letters in the text and producing them using only Japanese phonemes. So it uses only the speech sounds of Japanese. So of course I can do the same thing in reverse by taking the Japanese text and producing it using only English phonemes.
これは合成音声です。
So you can hear that the R in kore is kore. Kore wa gosei onsei desu. Right. So we can let's change that back to Japanese.
これは合成音声です。
Right. So you can choose your own language and you can choose your own text and have it produce whatever you want. you need to then, after you've synthesized it, you take this TTS object and use that to save the file, and then you can load the file back in using Librosa. That's actually too simple for one lecture. So what I decided to do in order to make the lecture a little bit more interesting is to use the speech recognizer to check the output. So I'm going to load the sound file app, which is used in order to read in, which can be used in order to read and write files. I'll use Librosa actually to read in the speech file, and then I will write it out as a .wav file, and I'll write it out as a .wav file so that I can then read it in using the speech recognition package. So Librosa can read in a wide variety of audio formats, but it can't write audio. In order to write the audio, we need some other package, for example, SoundFile. SoundFile can write out speech.wav with the specified data and sampling rate, and once it does that, then we can run the speech recognition package. Speech recognition doesn't work with MP3, it only works with WAV. So I can create a speech recognition object, and then using the audio file speech.wav as the source, I can read in that source, and I can try to recognize it in Japanese. Oh, I don't have speech recognition installed, so let me go ahead and install it. I forget if that's the right module to install. Um, was it capital S maybe? Let's find out. There we go. I've recently upgraded my computer, and so I had to reinstall the speech recognition package. Now it's installed, and so now we should be able to run the speech recognition package and do the text edit. The person in the file said, "Kore wa gosei onsei desu." This does not match the desired text, which was "Kore wa gosei onsei desu." It matched except for the space. And so we can do some normalization. We can take the desired text and replace every space with an empty string. Right? In Japanese, of course, the spaces are not syntactically important, and so we can renormalize it by getting rid of the space before we do the comparison. Once we've replaced the spaces with an empty string, then we find that it does match the desired text. And that's really easy, right? That's the sum total of this week's new material. I'm afraid that this week is very easy because all we're doing is introducing you to the Google Speech Synthesizer. So let's go ahead and open homework 14 and see what it includes. It really is just two different functions. The first function is to use GTTS to synthesize speech and then write it to the specified file name. And so all we need to do is to create a TTS object. And the key thing to remember here is the capitalization, right? Capital T, capital S. And I think it's text equals text and lang equals lang. We'll find out. And then we do TTS save to the file name. And if I've remembered all of the options correctly, that should be the complete homework. Let's see if that solved the problem.
This is speech synthesis.
There we go. So we called our function this is speech synthesis in English and saved it as english.mp3. Then we used Librosa to load the function english.mp3 and to play it back. And now we're going to use the speech synthesizer to create a lot of speech files and to check them. So the make a corpus function takes a whole lot of texts, a list of all of the texts that you want to synthesize, a list of the corresponding languages, and saves them in a list of their root file names. This might be useful, for example, if you want to train a speech recognizer using lots of synthetic audio. So we want to do something like generate a whole lot of text saying, "Hello, my name is, will the real Slim Shady please stand up?" And so we want to synthesize all of those in English, and we'll call them file 1, file 2, file 3, and file 4. So let's go ahead and find that. We have make a corpus with texts and languages and file names. Let's see, I think I want to I want to zip those up, right? I want to zip up the texts and the file names, languages. And for each of those tuples, I'll have one text and one language and one file name. And so I want to use the synthesize function to synthesize tuple element 0, which is the text, and tuple element 1, which is the language, and tuple element 2, which is the file name. And I want to return the recognized texts. So I want to perform automatic speech recognition. So I want to then take that file name. This is without the .mp3 ending, so I need to add to this plus .mp3 in order to save it, right? And then once I've saved it, I need to read it back in. Let's see, how do I read it back in? The way that I read it back in is by using Librosa. So I want to use Librosa load in order to load it back in, and then sound file write in order to write it out. And it looks like I have sound file and Librosa here. So let me go ahead and I will use data sample rate is equal to librosa.load tuple2 is the file name plus .mp3. And then once I've used Librosa in order to load it in, then I want to write it out using sound file. Let's see, is it soundfile.write? Soundfile.write, file name, the data, and the sample rate. So I want to write the file name, tuple2 plus dot wave, and I want to write it using the data and the sample rate. And then once I've written it in, I want to generate the recognized text. So I want a speech recognizer. Let's just copy that. And I want to take that speech recognizer and I want to use that to read in the audio file. How do I use the speech recognizer to read in the audio file? With speech recognition.audio file as the source. So with speech recognition.audio file as the source, and the audio file that I want to read in is tuple2 plus dot wave. I want to read in tuple2 dot wave as the source, and then given that source, I want to read in for the audio and recognize the text. So I want to read in the audio from the source and then recognize the text with the corresponding language. The language should be tuple1. And now that I've recognized the text, now I want to append that to the output. The output will be a list of the texts that are recognized. And so I want to append to recognized texts the text that was recognized from that file. All right, so we have synthesized the speech waveform, then read it in using Librosa, write it out as a waveform file using sound file, and then use the speech recognizer as the source, record the audio from the source, recognize it using the speech recognizer, and then append the text using the text. I think that's all I need. Let's find out if that seems to work in our test code. So we're running hello, my name is, will the real Slim Shady please stand up? And none type object is not iterable. For text, recognize text in O. For tuple, in zip texts, languages, file names. Why did zip not work here? Zip texts and recognize texts. Let's print out the texts and let's print out the recognized texts just to see what, maybe there's a bug in my code that I haven't seen yet. Let's find out. The texts were hello, my name is, and the recognized texts were nothing because I didn't return anything from the homework file. Once I've generated the recognized texts, I do need to return them. There we go. Return recognized texts, please, because I want to be able to append them to the original text to see what happens. There we go. Hello was recognized as hello. My name is was recognized as my name is. Will the real Slim Shady please stand up was recognized as will the real Slim Shady please stand up? And it capitalized real Slim Shady. Apparently, that phrase is sufficiently well known to Google that it was able to recognize it as a proper name. Let's check and make sure that that matches the grade.py. It looks like that matches grade.py. So now all we have to do is open up GitHub Desktop and check it in. All right, and let's go to github.com and make sure that it got checked in okay. Under lecture 14, we should now have, well, lots of MP3 files that we don't really need, but what we really care about is homework14.py. Looks like it's accurate. Okay, so copy this and go to the course, the course on Canvas and open it. And right now there is not yet a homework assignment there, so I'd better create one so that you can check it in. Let me go ahead and show you how to create a homework on Canvas. I want to create a homework, create an assignment. Oh, it's taking a while for some reason. You do not have permission to access this content. That's a surprise. Oh, well, it says it's there. Let's edit it. Let's change the title to Homework 14. And let's change the due date to July 31st at 11:59 p.m. my time, which is August 1st, early morning your time. We'll allow you unlimited attempts. And we will change it from, no, I want to save it. Unlimited 10 attempts, July 31st. Why is it not saved? Something has changed in the way that Canvas works for some reason. I think this should be saved, but it's saying that it's not saved. And we'll make it visible to students. I guess that this may be a difference between Chrome and Mozilla. So there's enter the URL of your copy of homework14.py. Let me try copying this over to Firefox and see if that solves the problem. Oh, this is Firefox now. Well, then let me try copying it over to Chrome and let's try Safari and see if that solves the problem. Actually, more often than not, it doesn't solve the problem, but let's just try it and find out. Oh, it didn't even log me in. This is very strange. I don't know why it should refuse to permit me to edit
Since
the settings.
Sensei, I think maybe today, 実は today is 日本の海の日です。I see the schedule. I didn't have any class in today. And I see the message to ask to you, and you didn't say that.
Oh, I didn't know that.
Yeah.
Oh, thank you. That would explain why there are so few people attending today.
Yes. So, do we still need come to next week?
I know I don't think so. I think that I had assumed that today was the last day. I didn't realize that today was a vacation. Um, yeah, I think that probably I will just post today's video and then people can attend next week as they choose.
So we didn't need to come to the next day.
Right.
Okay, thank you, Sensei.
Okay, so please go ahead and enter your homework. Maybe it's not fair to take attendance today then. So rather than take attendance, I will go ahead and simply post the lecture video and post an announcement on Canvas. And the homework is available. I need to change the due date once I figure out how to do that. But the homework should be available to you through July 31st. So you can go ahead and submit the homework at any time. Are there any questions? Thank you for attending and please uh, finish up the homework and have a good summer vacation. Thank you. Bye bye. Bye bye.
Bye bye, Sensei.